Welcome everyone. Today we're going to talk about using special angles for angles over 90 degrees. So let's dive in. First, we're just going to do a recap of what we talked about in our first lesson, and that was the special triangles. So we know that there are two special triangles from which we can get exact values for sine 45, cos 45, and tan 45, and sine, cos, and tan of 30 and 60. And these come from an isosceles triangle with side measurements 1, 1, and root 2, and half of an equilateral triangle where we have angle measurements of 30, 60, and 90, with the smallest side being equal to 1, and the remaining sides being equal to root 3 and 2. So from these, we can set up exact values from our trigonometric ratios, sine, cos, and tan, of each of these angles, and that's basically what we did in our first lesson. All right, so what is trig really? Well, when we learned about trigonometry in grade 10, it was all about right angled triangles and using sine and cosine. Well, it is about right angled triangles, but it's more about angle rotations. And angle rotations, basically, if we have a variety of points around the outside of a circle, I can use an arm to kind of rotate to any of those points. So let me give you an example. Let's say I have some point x, y. I go x units over to get to that point, and y units up. Now, we know that x and y meet at a right angle because x is horizontal and y is exactly vertical. Now, also, if I start at 0, 0, and I connect this to the point xy, I have a hypotenuse. And this hypotenuse is also the radius of this triangle. Now, if we measure thinking of the radius as like a swinging arm, if we start at this line here and measure up to our radius, we could call that some rotation theta. So this is kind of the idea that trigonometry is based on. It's rotations of points along a circle. And that actually means that although we have stuck in grade 10 with angles between 0 and 90 for right angled triangles, I can actually rotate past 0 and 90, and that's going to give me the ability to use sine, cosine, and tangent in angles that are actually greater than 90. Okay, so a couple terminology things that we need to know before we start here are initial arm and terminal arm. The initial arm is basically where we measure angles from. So the initial arm, you can consider this arm to be glued to the 0 degree line, which is this line right here. And it's glued to essentially the positive x-axis. Okay, so this is where we measure all angles from as a starting position. Sorry. Okay, so there's our initial arm. Now the terminal arm, think of the terminal arm as if it has kind of like a point that is glued to the origin, but it can rotate all the way around our circle. So usually we rotate in a counterclockwise direction from the initial arm, and then we'll rotate from there. So let's just say we have an angle measurement where we have rotated our arm all the way from the initial arm to this position here. This would be called our terminal arm. And it's basically an indication of how far we've rotated to get to that particular location. Okay, oftentimes we would call this some measurement of theta. So this rotates from the initial arm typically in a counterclockwise direction. To measure some angle theta. Okay, so the terminal arm essentially gives us a visual of what this angle theta looks like when it's rotated from the initial arm. So this one could potentially be maybe like 150 degrees or something like that, measured from the initial arm. Okay, a couple other things that we need to know before we actually start doing some examples here are when we're finding ratios of positive angles, so these are angles that are measured from the initial 0 degree line counterclockwise, we need the cast rule to help us determine which trig ratios are positive in each quadrant. So far in grade 10 trigonometry, we've been sticking between 0 and 90 for right angle triangles. So the cast rule helps us, and I'm going to show you how this works. So have a calculator handy. You want to be in degree mode, and we're going to write the word cast starting at the bottom quadrant and rotating counterclockwise. Now the quadrant names, just to remind you, are quadrants 1, 2, 3, and 4. So we actually start in the first quadrant, and we start in the fourth quadrant, and we label going from 4, 1, 2 to 3. Okay, so these each stand for a particular word. A stands for all, and basically what this means is if my angle that I plug into my trig ratio is between 0 and 90, all trig ratios will be positive. So if you have your calculator handy, I'm going to ask you to choose an angle between 0 and 90 for me. Okay, so choose whatever you want and practice with it. I'm going to choose sine of 61, and I want you to enter this into your calculator. Sine 61, cos 61, and tan 61, and just take note of which answers are positive and which answers are negative. So if I enter in sine 61, I get a positive, and then cos 61, I get positive, and tan 61, I get another positive. So this means all trig ratios in this quadrant are positive. So let's just do a little summary here. Sine of any angle will be positive, cos will be positive, and tan will be positive. Okay, the next quadrant is the sine quadrant. And we're going to want to choose an angle between 90 and 180. So any angle you want, you choose it. It needs to be between 90 and 180. I'm going to choose, let's say, 111. And then I'm going to take the sine of 111 in my calculator, then cosine, then tangent. So taking the sine of 111 in my calculator, I get a positive answer. Taking the cosine of 111 in my calculator, I get a negative answer. And taking the tan of something in my calculator, or taking the tan of 111 in my calculator, gives me a negative answer. Okay, so if you tried a different angle, you would have noticed the same kind of pattern. So let's just see, we're going to do the tangent quadrant, and then I want you to see if you can see what the pattern is here. So T stands for tangent, and this is for all angles between 80 and 270. So I want you to choose a sample angle between 180 and 270 and take the sine, cos, and tan of this angle. Pay attention to whether your answer is positive or negative. Okay, so for example, I'm going to choose 237 as my angle. When I enter in sine of that angle, I get a negative. When I enter in cosine, I get a negative. And when I enter in tan, I get a positive. So if we can kind of look at the results that we got from the first from the second and third quadrants here, sine was positive in the sine quadrant, but cosine and tan were negative. And then in the third quadrant, tan was positive in its own quadrant, and sine and cosine were negative. So I think we can make a guess on what's going to happen in this last quadrant. This is the cosine quadrant, and this is for angles between 270 and 360. And if you guessed that cosine would be positive here and that sine and tan would be negative, you would be right. So sine of any angle between 270 and 360, let's say we choose 305 as an example, sine will be negative, cos will be positive, and tan will be negative. So if we remember the cast rule can help us decide whether our ratio answers will be positive or negative in a particular quadrant. Okay, we're going to put this all together in a couple minutes. So if this doesn't quite make sense just yet, it's just building information so that we can apply it to questions. Okay, so angles over 90 degrees. We haven't worked with angles over 90 degrees yet, except when we did sine law and cosine law in grade 10. So angles over 90 degrees, if you ever have an angle over 90 degrees, it needs what is called a buddy. And the proper name for this would be a reference angle. So this angle's buddy is going to be a value, an acute angle value between 0 and 90, and it's going to help us determine the exact value when we're given angles greater than 90 or obtuse angles. So the buddy angle we can always find between the terminal arm and the closest x-axis. So this will either be the 0, 360 line or the 180 line. It's also necessary for you to know that only angles in quadrants 2, 3, and 4 will need a buddy angle because angles in quadrant 1, or the all quadrant, are already between 0 and 90. So if you're in this quadrant right here, if you're in this quadrant right here, you already have an acute angle and you don't need a buddy angle. Okay, so let's take our example of 300. So if this is my initial arm and I measure 300 counterclockwise, 300 is going to fall maybe about right here. So this will be 300 degrees. Now, my reference angle is going to be the angle that's formed with the closest horizontal and my terminal arm. So that's actually this angle right here. That's my buddy angle. Let's call that x. Okay, so if this is theta and theta is 300, then x must be that distance in this little slice right here. Okay, so here's what we know. I know that this whole rotation around is 360, and I know that this is 300. And so if the whole thing is 360, this whole slice right here, if that's all 360, and I know that the green slice is 300, then x must be the difference between those two things. So our reference angle here will be 360 minus our rotation, which is 300, and that's going to give me 60 degrees. Okay, so if I know that this is 300 degrees, this must be 60 degrees to make a full rotation of 360. Okay, it will be different in different quadrants. So I have a little kind of like summary for you here, and it's going to help you with finding reference angles. So in each quadrant here, okay, remember we don't need a reference angle in this quadrant, so that one is irrelevant. This one, your reference angle will be equal to your 180 subtract your angle. Sorry, let's just zoom in here a little bit. Just find a good spot to put this in your notes. Doesn't have to be right here. So your reference angle will be equal to 180 minus your rotation. In this one, your reference angle will be equal to your rotation, subtract 180. And in this quadrant here, just as we just did, it will be 360 minus your angle. Okay, so let's put this all into practice. First, we're going to draw the angle in standard position and find the buddy angle or the reference angle. So let's draw our quadrant grid. And 250, remember we start at the initial arm and we're going to measure counterclockwise from here. So it should be pretty close to 270, but not quite there, about 20 degrees before that to about here. So 250. So my reference angle is always the angle between that arm and the closest horizontal. So the way that I can find this, and if you use your summary above, that's basically what the summary above is telling you. The way that I can find this is by taking my angle and subtracting this piece of the rotation. Now this piece is 180 degrees. That's going to leave me with this remaining slice, x. So I'm going to find x by doing 250 minus 180. And that's going to give us 70 degrees. Okay, so similarly for 120, you're going to draw out your grid. And you're going to measure out 120 as best you can. If you have a protractor, even better, you can do it almost exactly. And we're going to get something like this. Okay, the angle that we're looking for, the reference angle or this angle's buddy, is going to be the acute angle between 180 and 20. Of course, we know the value between 180 and 20 is 60, but if I simply do the larger angle minus the smaller angle, that will give me my reference angle. All right, so here's how we're going to put all of this together. So I'm going to give you guys some steps, and we're going to follow these steps to find the exact value of angles over 90 degrees. Okay, so the first thing that you're going to do is you're going to draw your angle. In standard position. So looking at 210, you're going to draw out your grid here. Draw it a little bit bigger here. Oops. And you're going to measure from the initial arm 210 degrees in a counterclockwise direction. So that should end us right about here. Okay, now what you're going to do is you're going to find the reference angle, and the reference angle is this angle between 180 and 210. So that's the second part. Find the buddy or the reference angle. Okay, so in our case, if we're looking for this reference angle, we're going to do 210 minus 180, and that's going to give us an angle of 30 degrees. All right, so I have an angle of 30 degrees inside here. I'm going to complete this triangle and make it a right angle triangle with the closest x-axis line here. Now, I know if I have 30 degrees in my triangle, and that's my reference angle, that I can use special triangles for this. So if this is 30 and this is 90, that makes this 60. And I can label my sides accordingly. So I have 1 across from 30 always, and then across from 60. We have root 3, and the hypotenuse of this triangle is 2. So you're going to create your special triangle. Okay, remember this angle in this corner, this is our reference angle. So when we label opposite, adjacent, and hypotenuse, you're using 30 degrees as your reference. So this will be opposite, adjacent, and hypotenuse. Okay, the last thing here is now that we have a reference angle and we have the sides of our triangle, we also need to use the cast rule. So when I draw out cast here, I see that we've fallen in the tangent quadrant. So 210 is in the tangent quadrant. Now, if we think back to what we discussed earlier, the sine of any angle in this quadrant is actually going to be negative. It's going to give us out a negative ratio. So I know that my answer here is actually going to be a negative ratio. So here's what we do, guys. If the sine of 210 is in that quadrant, I'm going to use the reference angle in the cast rule to help me decide on what the ratio is equal to and whether it's negative or positive. I know that this is going to be a negative value because we're taking, sorry about the cat, because we're taking the sine of something in the tan quadrant, and it's going to be equal to the negative sine of the reference angle 30. Okay, so sine of 30, this is opposite over hypotenuse, which is 1 over 2. And that is our answer. Okay, so you can check this in your calculator. Ideally, you would be able to do these without your calculator, and I do want to see your supporting work here. But you can check this, double check it in your calculator, enter the sine of 210 in degree mode, and you should, if your calculator leaves things in fraction form, you'll get negative 1 over 2. Or if you're in decimal form and your calculator doesn't leave things in as fractions, you'll get negative 0.5. Okay, let's try another one. Okay, tan of 315. So first step, draw the angle in standard position. So 315, starting at the initial arm, rotating out from here is about here. Now the angle that I'm really interested in is the angle between my terminal arm and the closest x-axis. So that is the angle that falls between 315 and 360. So that's going to be 360 minus 315, and that gives me a measurement of 45 degrees. Okay, complete the triangle. You're drawing a right angle triangle, and that makes this the 45, 45, 90 triangle, where these two sides across from the 45s are 1 and 1, and the hypotenuse is root 2. I'm also going to use the cast rule here. And the cast rule is telling me that I'm trying to take the tan of something in the cosine quadrant. And we know anything other than the cosine of an angle in the cosine quadrant will be negative. So this is going to equal the negative tan of the reference angle. And because this is my reference, remember the angle inside here, this angle in here is always your reference. This is going to be adjacent, opposite, and hypotenuse. So we're looking for opposite over adjacent, and I know the answer will be negative here. So it would be negative 1 over 1, which simplifies to give us negative 1. So that will be our solution. You can check your answer by entering in tan of 315 on your calculator, and you should get negative 1 out. Okay, so far we've talked about rotating only counterclockwise, but we technically can also rotate clockwise. It just basically means that your angles would be expressed as negatives. So we have an example here. I will make an example. So for example, if I wanted to measure the angle negative 120, this simply means that I'm going to start at the 0 degree line and measure 120 degrees, but this time in a clockwise direction. Okay, the easiest thing to do when you're trying to find sine, cosine, or tan of negative angles is just to switch them into their positive rotation, which makes the terminal arm land at the same point. And we can do this really easily by taking 360 and subtracting the angle from it, and this will give us the positive rotation of that angle. Okay, this essentially just gives us an equivalent rotation in the counterclockwise direction, which causes the terminal arm to land in the same spot. Okay, so if we were to find the exact values of these particular values here, the first thing that I would do is switch the negative angle into a positive angle by subtracting it from 360. So this one will give us 315. So what I really want to find here is the sine of 315. Now I'm going to follow the steps above by drawing the angle. We actually drew this in our previous example here, so I'm just going to write it out. I will find the reference angle, which is the angle between 315 and the closest x-axis, which would be 360. So we already found that in the previous example. Here is our reference. Let's complete the triangle based on our special triangle information. And we're going to use the cast rule. So we are in the cosine quadrant, which means that the sine of 315 in the cosine quadrant will be negative. And based on this reference angle in this corner, I'm going to label my sides as adjacent, opposite, and hypotenuse. Now, because we're doing sine, we want to think SOHCAHTOA. Sine is opposite over hypotenuse, and I know this is going to be equal to a negative because of the cast rule. So this will be equal to negative because we're in the cosine quadrant, sine of 45 because that's the reference angle. So opposite over hypotenuse is negative 1 over root 2. Or if you'd like to express this with a rationalized denominator, negative root 2 over 2. Okay, we're going to solve the last three similarly. Switch this into a positive angle by subtracting from 360. That will give us 300. Draw the angle in standard position. If 270 is here and 360 is here, 300 will fall maybe about here. Maybe a little bit further. Something like this. And I'm interested in this angle in between 300 and 360. Of course, we know the angle between 300 and 360 must be 60. And you're going to create a right angled triangle from here. So complete your triangle, 30, 60, 90. Remember, 1 always needs to be across from the smallest angle, which is 30. Root 3 is always across from 60. Oops. And the hypotenuse of the triangle is always 2. Now, based on our reference angle of 60, that makes this adjacent, opposite, and hypotenuse. Okay, the final thing that we need to consider is the cast rule. And the cast rule tells us we are in the cosine quadrant. And because we're taking the cosine of something in the cosine quadrant, our answer will actually be positive this time. So this is going to be equal to the positive cosine of the reference angle, which we found to be 60. So cosine of 60, think SOHCAHTOA. Cosine of 60 is adjacent over hypotenuse, which is 1 over 2. And again, it's positive because I'm taking the angle, the cosine of an angle between 270 and 360, which is in the cosine quadrant. Okay, last one. So let's switch the negative angle to a positive angle. This is going to give us 120. So this should be equivalent to the tan of 120 degrees. We're going to draw this out. And 120 is approximately, let's do this in another color here. It's about right here if we measure from 0. And I'm interested in the angle that falls between the 180 line and the 270 line. We've actually found a reference angle for this in a previous example. And you're going to complete the triangle here by creating a right angle triangle, always with the closest x-axis. Okay, that is an important piece of the information here. So here's our reference angle. Complete your special triangle. And label your sides based on 60 as your reference angle. This would be adjacent, opposite, and hypotenuse. Okay, the last thing that you want to consider again is the cast rule. And we are taking the tan of an angle that is in the sine quadrant. This tells me that my ratio will be equal to the negative tan of the reference angle, which is 60. So considering SOHCAHTOA, tan is equal to opposite over adjacent, and it's negative because we're taking the tan of an angle in the sine quadrant. So you should end up with negative root 3 as your answer here. Okay, sometimes I have questions from students like, what if our reference angle is not 45, 30, or 60? And the answer would be, then we can't find the exact value. So this only works for angles that are producing reference angles or buddy angles for us that are 30s, 60s, and 45s.